So our first question is this question here. So it says, which shows two triangles that are congruent with the SSS congruence theorem? So what I'm going to do is I'm going to give you a minute, pause and think about this question, and then we are going to work through the solution together. So let me while we're pausing, let's just so I would encourage you, if you're in the chat as well, maybe wave hi, and also if you have any questions or any concerns about this problem, feel free to let me know in the chat. But I'm gonna give you a minute to think about this question, and then we're going to answer the question and look at the solution together. So it says, which shows two triangles that are congruent in the SSS congruency theorem. So these are I have four triangles here. So maybe I don't know if I can put all four of them for you, but this I'll show you the first two and then the second two as well. So let's see. So this question is two triangles that are congruent with SSS congruence theorem. And again, this question would be under geometry, right? Because we're talking about congruence theorem, we're talking about triangles and sides and angles as well. So this is a geometry question. So this is option A, option B here, option C, and then option D. So let's look at these triangles here. I'm not going to draw it out here because it is already given to me, but I'm going to maybe write like this is option A, and the thought process behind that, and then option B here, and then maybe I'll write down option C and D here. So I'll take a minute to think about this. I'm going to scroll and show you C and D as well. Again, so the question is asking two triangles are congruent with the SSS congruence theorem. So first, I would think to myself, what is the SSS congruence theorem? So again, SSS is a shorthand for side. So what we're saying is we have two triangles with all three sides that are equal to each other. So they're equal in length. Therefore, if they're equal in length, then they have exactly the same three angles. That's what we're proving, right? So three sides, if they have the same length, it means my three angles are also the same, which means my triangles are congruent to each other. So let's look at a question. Let's look at A first here. So A here we have PQR and RST as our triangles. As you can see, this dash here and this dash here means that they are the same length for this side and for this side. So PQ. So let me do this. So PQ or QP, sorry, QP is equal in length with ST, right? Because they're equal, and then PR is also equal in length to RS, right? Because I have these two dashed lines represent that they're equal to in length. So two sides are equal to each other. But what about QR and RT? Are they equal to each other? Are they equal to each other? And RT, are they equal to each other? In this case, no, right? I don't have lines that signify that they're equal to each other. And if I kind of deduct this like visually, I can see that QR is much bigger than RT, which means that this does not follow the SSS congruence theorem because all three sides are not the same. So in this case, A is not our correct answer. So this is incorrect. So I can say this is incorrect. So let's look at B. B here, we have PQ, and then we have PQR as a triangle and RST as a triangle, right? So let's look at this problem here. And as you can see, I have two sides are equal to each other, right? I have PQ is equal to ST, right? So that's good. So PQ is equal to ST, which is awesome. And then what about PR? What about this, like PR and RT? Do we know if that's the same? In this case, we don't know if it's the same, right? This length here and this length here, we don't know if it's the same because I don't see the lines here, and they're not part. They don't share. The two triangles don't share a side. So in this case, PR has no relation to RT, so it's not equal to. And same with the SR here, or QR in this case, and RS, right? In this case, they're also not equal to each other based on that reasoning as well. So they're not equal to each other. RS, which means in this case, again, option B is also incorrect because I only have one side that's equal. In this case, I had two sides are equal. In this case, I had one side that was equal. I need three sides, right? SSS is three sides for me to prove congruency. All right, let's look at C. So see here, I have PRQ and then PSQ as my triangles. So PR, as you can see, this dashed line equals PS, right? These two lengths are the same, so that's good. So it's PR equals PS, which is great. I have here RQ and SQ are the same, right? The two dashed lines, these two are also the same as well, right? So they're the same in length. So RQ is the same as SQ. And then what about PQ? This last line here. PQ in this case, because the two triangles share the side, they would have to be similar, right? So PQ equals PQ in this case, right? PQ equals PQ, right? They have the two triangles share this side, right? So again, it has to be the same length. They share the same side, which means actually this answer is correct because I have here, this is three sides are equal to each other. Equal. So therefore it's congruent, right? Therefore it proves that this is congruent. Sweet. So let's just so that's C is our correct answer here. But let me prove to you that D is not the correct answer here. So I have PQR and RST here. So again, this side QR, I have the line here and the line here, right? So QR is equal to RS. That's good. That's one side that's equal. So QR equals RS. And then I have here again. I look at the angles here. Right? This angle and this angle, the angles actually in this case don't really matter because I'm looking at the side congruence theorem, right? So QP is not equal to RT and PR is not equal to ST. There's no relation that has that says that these two are same in length. So which means I can say that QP does not equal RT, and the last side was PR does not equal. This would be ST. So in this case, only one side is equal. So therefore it's not congruent, which means that my answer here is C, right? My answer, because I have three sides that are congruent, or three sides that are equal to each other, which means my triangle is congruent. So let's see if they got the same answer here. So option C is correct answer. That's good. Since two triangles are said to be congruent, their corresponding sides and equals are equal, right? So SSS means that the two triangles are congruent if the corresponding sides are equal, right? All sides have to be equal. That's good. So in figure A, only two sides are equal. That's good. So not congruent. Only one side is equal. Good. Figure D, only one side and one angle are good. So once I didn't choose to focus on the angles here. They did, which is awesome, which is even better because we have like SAS, for example, is also a congruency theorem as well. But I chose to focus on the sides because the question asked side congruence theorem. So I only focused on the side. Therefore, these two triangles are equal, right? So I have option C, right? So PRQ is congruent to PSQ, right? And that's what they have here. PRQ is congruent to PSQ, hence the answer. Good. This is a perfect solution, and it is a great step-by-step perfect solution and analysis. Sweet. That's correct.